This is an AIPMT question that we are solving in current electricity. The question says, what will be the equivalent resistance of the circuit shown in the figure between the points A and D? This is your point A, this is your point D. Whenever he want resistance between any of the 2 points, we shall imagine a battery between the 2 points and try to understand how the current flows in the circuit when the battery is connected between the 2 points. So, imagine a voltage V is available here. So, from here a current I starts. I after going here, entire I will pass through this 10 ohms, but after reaching this junction it divides into parts. This becomes I1, let it is I2. So, that I1 after coming to this place can go towards C or towards this 10 ohms. But if you look at the point C, this is a open end, C is open end, it is not connected to any of the circuit. It is a open end means current after going to that point has no way to return back to the negative plate of the battery. That means it is a dead end, it cannot come back to the negative plate of the battery, it is an incomplete circuit, therefore, it will not go to that 10 ohms, this 10 ohms itself. Means what? This 10 ohms though that is physically there, no current passes through this. So, this is a dead element of the circuit. So, what I can say is resistance at C is a dead element of the circuit and no current flows through that. So, the entire I after reaching this junction, no current goes towards the C, it is completely going to this 10 ohms. So, if you notice this 10 ohms and this 10 ohms are having the same current through them. When the current is same, that means they both are in series. That implies what we can say, 10 ohms is in series with 10 ohms. So, R series can be written as, we know the formula, R1 plus R2, that is 10 plus 10, that is 20 ohms. That is what are we talking is this part of the circuit. Now, let us have a look at this I2. Again I2 after coming to this place has to split between these two. Again the same story, B is a open end, it is a dead element, it is not only C, B is also a dead element, no current flows. Therefore, though this is physically there, it is not going to contribute any current or resistance to the circuit. So, what happens is that I2 will further go to this 10 ohms. So, if you notice this 10 ohms and this 10 ohms are also carrying the same current I2, that means they two are also in series, these two are in series. So, when they are in series, their effective resistance is again 20. So, if you have to draw an equivalent circuit of this, you can draw this as 10 ohms at the point A. Instead of this two 10, instead of these two who are in series, I can draw a 20. Instead of these two 10, I can also draw another 20. So, what you can notice is, and of course, there is remaining this one, I1 and I2 will join here, it becomes I, it passes through this 10 ohms and this point is T. So, what we can notice is this 20 ohms is in parallel to 20 ohms. When the two resistors are in parallel, R parallel equal to, we have a formula R1 R2 by R1 plus R2, but R1 is 20, R2 is also 20, R1 plus R2 is 20 plus 20, that is 20 into 20 by 40, that is 20 by 2, that equal to 10 ohms. So, again I can draw an equivalent circuit as 10 ohms, 20 and 20 is actually 10 ohms, and there is another 10 ohms, this is D, this is A. So, it is very clear they are all in series, pass the same current. So, resistance between AD is, as they are all in series, R1 plus R2 plus R3, that is 30 ohms is the answer for the problem. This is how we have to solve the problem. So, I want you to tell you this point again by stressing that whenever you want a resistance between any of the 2 points, just imagine a battery between the 2 points and see how the current distribution happens, so that you will be knowing easily who is in series to what and who is in parallel to what. That is how we have to solve the problem to get the answer of 30 ohms. Thank you for watching.